Due to the lockdown, some of you did not get the trigonometry you needed in the spring, and others of you may need a refresh. So I've made a simple introduction to trigonometry just to get you a little bit up to speed. Now understand, this is several weeks of work in a regular day school setting, so don't be hard on yourself thinking, wow, this was a lot to take in. Trig goes back thousands of years, and ancient India had some rather interesting takes on it as well. This is the value of pi in an ancient Indian language where all the numbers were metaphors. So I think you'll find writing 3.14 is easier than writing Vabuddha eyes elephant snakes. It's a rather picturesque writing system. This was Madhava from the 14th century. The value of pi and the circle is essential to understanding trigonometry. The first part of trig you usually know is Pythagoras' law, which connects the sides of a right angle triangle that we label A, B, and C. And you get c squared equals a squared plus b squared. So you can figure out the length of a missing side of a triangle by using this formula and rearrange to solve for whatever letter you want. The sides of the triangle get a name. The side of the triangle that is touching the angle theta is called the adjacent. The side of the triangle that's across from the angle is the opposite. And the long side of the triangle, which is directly across from the 90 degree, is called the hypotenuse. If instead of talking about this angle, I wanted to talk to the angle up here, then this would become the adjacent and this would become the opposite side. When you try to draw an angle, you typically start on the x-axis and you swing up a certain angle and then you may travel a certain distance. This is called a circular coordinate system. You've used protractors before. The teacher might say, I want you to draw a 30-degree line from the horizontal and make it 10 centimeters long. But another method is to tell me the x and y coordinates of a spot. So you could say, I want you to go 3 over and up 4. And what the trig functions do is they connect the idea of an x and y value with an angle and a distance. It puts the two systems sort of together. Each ratio of a triangle uniquely links to an angle. This triangle, if the opposite and the adjacent sides are the same length, 1 and 1, 2 and 2, 10 and 10, pi and pi, 6.34 times 6.34, on both of these, the angle is going to be 45 degrees. What happens if this triangle is twice as long as it is tall? Then uniquely that ratio links you to a 26.5 degree triangle. If the ratio is the opposite, it's 1 unit across, 2 units tall, then uniquely that's a 63.4 degree triangle with a lot of rounding. We could also do 1 to 1.41, and that is also a 45 degree triangle. If the adjacent is 2 and the hypotenuse is 2.2 as a ratio, then that is also a 26.5 degree triangle. All the possible ratios in there from the adjacent, opposite, and the hypotenuse side, those ratios will be unique for a given angle. So we name these 3 ratios, and there's only 3. You can compare the adjacent side length to the hypotenuse and the opposite. You can compute the opposite side with the adjacent and the hypotenuse, okay? So we have opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Those are the only 3 ratios that can exist on a triangle. And somehow these ratios are connected to the angle. They don't equal the angle, they're connected somehow. In the same way that your pay is connected to the time you work. there might be some underlying equation that allows you to turn the time you work into money. $20 an hour times time. So we need to find that mathematical connection between the angle and those ratios. The three names of these ratios are sine, cosine, and tangent. And they're all on your calculator. So you should eventually learn these and have them committed to memory. Now, how do we get these ratios? Well, what you need is an ancient country prior to cars, prior to beaches, prior to music, prior to computers, and you have nothing to do. You sit on the sand and you just throw rocks and hope that warlords don't come and get you until you die of impacted wisdom teeth when you're 27. This required centuries of people with no social life or activities at all. And they sat there in ancient times and they would draw a 45-degree triangle and they would get 1 to 1. Then they would try a 46-degree triangle and see what the ratio was. Then they'd try a 47-degree triangle. Then someone else came along and said, oh, no. I'm going to do 24.1, 0.2, 24.3, 24.4. And they wrote all these ratios down. And let me tell you, these are cliffhangers of reads. There's such an excitement when you read that the sine of 24 degrees is 0.4067. Oh, but 24.1, the sine of that angle is 0.4083. These are real page turners, right? So you can imagine the exciting lives you had happen if you decided to draw out triangles of every angle that could exist and measure their ratios. I am the last generation. I am very different from you in the fact that I was the last generation of kid that got to use these tables because calculators were a fortune and about the size of a mini fridge when I was a child. And I remember the first calculator that I could carry under my arm like a binder. And you'd plug it in the wall and the lights would dim. They were so big. And I also have a smallpox vaccine scar because I'm the last person to get the smallpox vaccine. So smallpox come back. I live. So yeah. So these ratios, somebody calculated them all. And if there's ever the loss of our technological society, people are going to go running back for these tables. So instead, we can trust our calculator. Is there some formula that lets us take the 1-to-1 triangle that we know would have a 45-degree angle and actually convert it to the angle? And the answer is not really. The sine and the cosine and the tangent formulas are more or less infinite. You will learn these formulas in university, maybe around second year university, first year university math, and they take your ordinary polynomial, x squared plus 2x plus 3 equals 0 kind of thing, and it will dwarf them. They will be gigantic functions. So what you're going to do is just have faith that your calculator can do it. Somehow, when you take theta, the angle, and you hit sine of that angle on your calculator, it will give you the ratio. It will do some mathematics behind the scene. And once again, to date myself, I remember when I was a teenager, and if you typed in 3 squared on your calculator, it would hit 9. But if you typed in sine, you could literally watch the calculator take a moment or two to calculate the answer. And we would have contests going, yeah, my calculator did it in 3 seconds, suckers. And somebody else goes, mine did it in 2. You could actually watch the machine take time to calculate it. So you are going to link the angle given with the side lengths of the triangle using your calculator. Okay? Let's take a first example. What is the ratio of opposite over hypotenuse in a 60-degree triangle? So I set up a triangle that's 60 degrees, and we're only going to talk about the opposite and the hypotenuse side. Well, if I tell you the triangle is a 60-degree angle, then you press sine 60 on your calculator. Now this will vary. Some calculators require you to type 60, then hit sine. Some calculators let you press the sine key and then enter the 60. And you can generally tell. If you press the sine key and it just says 0, then it was expecting a number first. If you press the sine key and your calculator literally displays on screen SIN and an open bracket, it's going to let you type the letter in later. Most calculators, it still requires you to type 60, press the sine button, and you will get this answer. This means that a 60-degree triangle, the opposite over hypotenuse side is 0.8660. What this is really telling you, the opposite side is 86% the length of the hypotenuse. So if I tell you the hypotenuse is 5, then you can say opposite equals 0.8660 times h. You rearrange, and you get 5 times 0.866. You get that the other side, the opposite side, will be 5.866 across. Okay? Now, a triangle has sides 5 and 7. What is the angle theta? Well, if the opposite is 5 and the hypotenuse is 7, the sine function says it's 0.71. Now we got to go backwards from the sine to the angle. And the way you do that is with the key sine to the -1. That means the inverse, the opposite. You may see it on a shift key on your calculator, or you have the letter INV for inverse. You type in 0.71, hit inverse sine, and you get 45.58 degrees. These are the two ways of computing something with the sine function. Okay? The cosine function is the adjacent over the hypotenuse. We don't care about the vertical side now. We're going to look at these two sides. What is the ratio of adjacent over hypotenuse in a 60-degree triangle? Well, if you type in cosine of 60, you get a half. This means the adjacent side is half the length of the hypotenuse. Rearrange the formula, you get 2.5. Let's go backwards. A triangle has sides A is equal to 5, hypotenuse is equal to 7. What would be the angle on such a triangle? First of all, you can see that the triangle is shorter than the long side. The A over H ratio is 5 to 7.71 again. We want to reverse that cosine, so we take the inverse and we get 44.41 degrees. Now remember, don't compare it to the previous one. I've changed the numbers in the triangle. Finally, we get to the tangent function. It connects the opposite and adjacent. So if I said to you, what is the ratio of O over A in a 45-degree triangle? Well, first of all, you already know in a 45-degree triangle, the answer should be 1. And if you type in 45 and hit the tan key on your calculator, it will say 1. What if I gave you a triangle and I said it's 5 units long and 20 units tall? What is the angle? Well, first of all, you know it's going to be very steep. You take your ratio, you get 4. Now you have to go backwards from this ratio to get the angle. So you would type in 4, tan to the -1, and you get 76 degrees. In physics, how would we use this? The two most common uses is to assemble the sum of two 90-degree vectors. So let's say we have the submarine that fires a ridiculously large torpedo for the size of the sub, and the torpedo is moving at 30 meters a second to the right, but the water itself is moving 5 meters a second down on our screen. Okay, so the torpedo is going to be traveling on an angle similar to when you try to swim across a river in a current. So how do we figure out the actual speed and bearing of this torpedo when it's fired? Well, step one, we can get the size of it using Pythagoras' law. To make life a little bit easier, we can take the units off until you're comfortable with trig. And we will get, using Pythagoras' law, we take 30 squared plus 5 squared, take the square root of it, we get 30.4 on the diagonal. And that seems to be reasonable from the sketch. VR simply means the resulting speed. How do we get the angle? Well, to do the angle, we need to do opposite over adjacent.